Rain's here. Jacob is here. Patricia is not here. Fred's here. Anthony's here. Krisha's here. Angelina's not here. Rita's here. Jake's here. Caitlin. Gotcha. Andre's here. Lena's here. Joey's here. Although unrecognizable, he's here. Awesome. Gabrielle is here. Gwenny is here. Addison's here. Madeline's here. Marcus. He is here. Good, yeah. Avezi. Charlize is here. Samir is here. Done. Okay. Okay, well, okay. One second here. Interesting. Okay. Yes, good. Page 215. 1 to 4 AD. Yeah. Uh-huh. Okay. So it says most commercial trucks are diesel fuel. Consider the following reaction. Heptane. So heptane is a component of diesel. So this idea of combustion, this idea of combustion is actually something that you can relate to. When you hear the word combustion, think of basically burning. You're burning something, in this case, fuel. So you're going to get heat released. Heat is going to be released from this, along with the carbon dioxide and water. So if we want to be a little bit more precise, we'd say heat as well. Okay. Now, this is called, because it's burning the diesel fuel, this is called a combustion reaction. I'm not too worried about, I'm just introducing this idea to you. We'll cover this more in detail later. This is in preparation for that section. So how do you know it's a combustion reaction? Whenever you have a hydrocarbon, something made up of only carbon and hydrogen plus oxygen, it's going to burn, such as the diesel fuel. Such as methane. Remember that? Methane is another example of something that burns. It's a gas. This is liquid. This is a gas. Either one will burn, catch on fire, and produce heat. Here's another word for you. When a reaction produces heat, it's called exothermic. Oops. Producing heat. It releases heat. Again, we'll talk more about that later, but just so you're aware, there's a fancy word for that, for releasing heat. It releases the heat to the surroundings. We'll add this in. Releases heat to the surroundings. Releases heat energy. It's a form of energy. to the surroundings. Okay. Now, in part A, it says lists the reactants. The reactants are what are reacting. They react together. So the heptane reacts with the oxygen. That's why they're called reactants. The oxygen allows the heptane to be burned. They react together. So it's always the left side of the equation that are reactants. And this plus sign means simply they react. Heptane reacts with oxygen. Okay, B, formula of the products. Products in a combustion reaction are always the same. Carbon dioxide and water. This plus sign means that they're two different products. They're separated. Separates them. Okay, what is the coefficient of CO2? It's this. The number in front is the coefficient. Okay, D, I kind of anticipated this. What's the meaning of the plus sign? On the left side of the equation, it means reacts. So on the left side, you've got clean this. They react. The screen is dirty. Sorry, guys. I'm able to write with it. No, this is running out of energy. Okay. So the plus sign means they react. Whoa. That's D. 2, study the following diagram. This is kind of a weird question because they give you the answer. It says, study the following diagram and then write a skeleton equation. Skeleton equation is this, just H2. It's without the coefficients. It's already given to you there. Skeleton equation is without the coefficients, so they kind of informally gave it to you. So, notice something. When hydrogen is by itself, instead of, if you were given the word hydrogen, you would not write H. You'd write H2. Same thing for nitrogen. If you started off with a word equation, you would not write N. You'd write N2. Okay? As opposed to this. Now, how many you got as far as hydrogen when it's combined with another element? Well, that's up to the element. Okay. So when it's by itself is when it comes in pairs. We call them diatomic. Di meaning two. So which elements are those? You got to memorize this. Well, it's hydrogen, obviously. And then if you get out your periodic table, can you get that out? Grab your periodic table. Look for this region. What the heck? Even I forgot it. NO, this is fluorine, right? I made a mistake. NOF, NOF, CL, BR, and there's one more. Yeah, just make sure you know where that location is. It's an inverted upside down L. 3. Okay. AL F2. This is kind of the equations you can expect on the test. It'll be right from question number 1 on page 211, which are this type. You don't have to figure out the formulas. They're already given to you. You just have to put coefficients in front. Before we start, what type of reaction is this? Yeah, 2 elements coming together to form one compound on the right. Synthesis. By the way, just on a side note, just so you know, these reactants are higher energy. Higher energy. This is lower energy. When it forms the compound, why is it lower energy? Because it releases heat. Which means this is exothermic as well, just like the combustion reaction. It's exothermic. Heat comes at the end. It's given off. Making this, I'll underline it in yellow. This is lower energy. What I underlined is lower. Where did it lose its energy? It released it. I'm going to look up something here. Yeah, good. Okay, now we can balance it. I'm going to just copy it. Okay, so these are, obviously it's not balanced. This is a little bit more on the easy side, so you can just guess at it. So notice there's a 2 here, there's a 3 there. It's not balanced. Let's guess. Let's find a number that 3 and 2 go into, the smallest number. So I'll put a 2 here, and now I have 6 fluorine. And 2 fluoride. We'll come back, or 2 aluminum. We'll come back to that in a second. So 6 fluoride, 2 fluoride on the left, put a 3 in front. Now it's balanced for the fluoride, but not the aluminum. I've got 2 aluminum here on the right. Put a 2 there. Quick way of doing it. Okay, next, PbCl4. Hey.
Mr. Glowneck wants us to take a picture with you.
Let me think about that. No. No, I'm kidding. I'm just kidding. I'm not that mean. But he's interrupting my class. Tell him that's rude. Not you guys. He's rude. Is that kind of like part of the? Yeah, of course.
Okay.
Take care. Are there more coming? Okay. Let's look at this. So, ionic compound. How do I know it's ionic compound? Starts with a metal. Ionic compound starts with a metal. I'm just going to put ionic, but it means ionic compound. What type of reaction is it? If it starts with a metal, ionic plus ionic. Yeah, these 2 metals, that's going to be replaced. That's going to be replaced. You can see here, the Pb is replaced with a K. They switch places. So it's called double replacement. Okay. Double replacement. It is not balanced. We're going to balance it. This is Mr. Glownick's way of saying, I didn't have time to prep last night, so I'm giving a scavenger hand. I'm bugging Mr. C on top of it. PB. C out. Now, before I go on here, let's take a look at look at this. I recognize it. You've got to get familiar with it. Guys, I'm assuming at the back there's Samir that you're looking at the screen where I'm putting up equations and I'm going to balance, and that's what's funny. Okay. Look at this. I recognize it. That's the only way it's going to stand out. If you go over the second page of your data booklet and make sure you know the difference. Polyatomics. Okay. So I recognize PO4. It's phosphate. I'm going to check to see whether it's on the right side. It is. So I can write it down. PO4. How many more are coming? Because this is getting disruptive, seriously. You know what? Yeah. You know what? Tell them no. No more pictures. I got a class to teach. No. Like, really. Why doesn't he tell them to take pictures of Mr. Blash? See how that works out. Okay, now. 1 PB. 3 on the right. 4 chlorine on the left. There's a 4 here, 4 on the left. On the right, there's no subscript, only 1. PO4. Let's look at this. No brackets, which means there's only 1. PO4 on the right, there's brackets, which means there's more than 1. There's 4. Okay, K3 on the left, 1 on the right. Is it balanced as it is? As it stands? No? No. Okay. It's not balanced, but we can balance it. We're going to try. I'm just going to guess. I'm going to try to balance the lead first, the PB. There's 3 on the right. I'm going to make it so there's 3 on the left. Now there's 3. But it also affects the chloride. It's 12. 3 times 4 is 12. Oh boy, how do I make it so there's, again, this is trial and error, so you need to do this with pencil. We'll see if this works. How do I make it so there's 12 chloride on the right? Yeah, put a 12 there. And now I've got 12. You can see this is getting messy, but let's see if we can fix it. It also affects the potassium. So I have 12 potassium on the right. How do I make it so there's 12 on the left? I put a 4 in front. There's now 4 times 3, 12. It also affects this. Originally, there's no brackets there, right? Originally, there's 1. 4 times 1 is? Yep. 4. Is it balanced? Done. I fluked out. I just knew from intuition. But you may need to take your time and erase it if you make mistakes. You can see it gets a little messy. That's okay. See, BR2, notice it's a BR2, not a BR. They come in pairs. Fe, I2, or excuse me, I3. Produces, notice iodine when it's by itself comes in pairs. It's I2. Okay, before we begin here, this is element plus compound. What's being replaced? The iodine. In this case, it's the iodine being replaced. Yeah, single replacement. What's it being replaced with? The bromide. So, just so you're aware, this is a non-metal. It's always going to replace a non-metal. Sometimes it's a metal being replaced, sometimes it's a non-metal replaced. This is called single replacement. Thank you, I appreciate it. Are they coming to bug me again? Okay. Oh, hey. Okay, let's take a guess. I would, a little bit more on the difficult side, make up a table. If in doubt, draw a table. Come up with some sort of list. VR, FE, and I. 2 on the left, 3 on the right, 1 FE on the left because there's no subscript, 1 on the right. Iodine on the left, 3. I'm just counting ions or counting atoms. Six. So 3 times 2 is 6. And then 2 times 3 is 6. So bromide is balanced. The 2 also affects the Fe. Two times 3 is 6. Almost done. Put a 3 in front. Done. Okay. D, Na2, CO3, I need more room. Yeah. Go ahead. Okay, so what stands out for me in this equation is the carbonate and the nitrate. You have to make sure they're on both sides. The carbonate's here, it's also here. Check. You also have to check for the nitrate. It's here, and it's here. Which means I can make a list. I can now, instead of separating the carbon and the oxygen, I can write CO3 and I can write NO3. This makes it faster. So it's just a matter of counting ions. 2 sodium, 1 sodium. No brackets, which means there's only 1 of them. Brackets, there's 3 of them. Chromium, no subscripts, which means 1. On the right, no subscript, 1. Should be, I made a mistake here, should be a 2. Should be a 2 there, so it is 2. Okay, on the left, 3 nitrates, and on the right, no brackets. What does that mean, no brackets? How many are there? 1, good. We're not balanced. Let's see if we can balance it. I'm guessing. I don't know. I'm going to try. I don't know. This may not work. Let's try the chromium first. I need a 2 there. 2 multiplies with 1 to give 2. 2 multiplies with 3 to give 6. Balance the nitrate. Put a 6 in front. 6 times 1 is 6. It also affects the sodium. 6 times 1 is 6. Go to the left side. Put a 3 in front. 3 times 2 is 6. Okay. There's only one of these. Keep circling it. There's no brackets. So 3 times 1 is it balanced? I fluked out. Okay. You may have to do this a couple of times. I'm trying to save time for us. You probably won't always get the right step the first time. So take your time with it. E Mn plus I2 produces M, and I'm just going to give this to you. I'm going to do it quickly. There's a 2 in front of here. Done. What type of reaction is this? Element plus element. Synthesis. The synthesize means they combine and form something new. They come together and make something new. Synthesis. In general, what type of reaction is this as far as heat? Is heat added or is it released? Yeah. So it's exothermic. When it releases heat, when heat comes at the end of an equation, called exothermic. It's expelling heat. Exo. F C2H6 plus O2. What type of reaction is this? Combustion. Good. It's not balanced. I'm going to see if I can do it fast. Should I do it fast? I'm going to do it with a table, just in case. What's that? Nothing? Did someone pass some of this at the back? I don't want to know. Okay. Carbon, hydrogen, oxygen. Yes, it's a combustion reaction. Okay. Let's balance it first. We can talk more about it in a second. So there's 2 carbon on the left, 1 on the right. No subscript, which means 1. Hydrogen, 6 on the left. On the right, 2. This is the hard part. On the left, there's 2. That's easy. On the right, there's 2 oxygen here, plus 1. Don't forget the extra oxygen in the water. Okay, let's balance. Balance the carbon. Put a 2 in front. That also changes the number of oxygen. 2 times 2 is 4 plus 1. 5. Okay, we'll come back to that. Carbon is 6 on the left. Excuse me, hydrogen is 6 on the left, 2 on the right. Put a 3 in front. Does this coefficient affect anything else other than the hydrogen? Yeah, 3 times 1 is 3, plus the 4 here. 7. What times 2 is equal to 7? Good. Whoa. 3.5. You can't have 3.5 molecules. So what's the trick? Yeah, you can put it in brackets. multiply. That means multiply each coefficient by 2. I'll rewrite it. 2, just double each coefficient. Now you got 7, which is a whole number, which you can have. Whole number of oxygen molecules. 2 times 2 is 4. I'm just doubling the coefficients. Plus 6. Now you're done. Complete. Okay. G. Going to take too long. I'm going to go through this one quickly, give you the answer. Just write it in for you. What type of reaction is this? Yeah, double replacement. Okay. I can look at the answer. Save me time, save you time. So there's a 2 here and a 2 here. That's your answer for that. Yeah, and it is double replacement. I just put DR. H. Here's a new one. This is, okay, tell me what type, don't tell me yet, but in a minute. Tell me what type of reaction you think it is. Who is that? No, I'm not going to freaking it. No pictures. No. Fast. Like 1 second fast. Like. Okay, I know, I'm a pushover. Enough. Okay. What type of reaction do you think this is, given the structure? Yeah, I would, not combustion, but double replacement, right? Ionic, you think that's ionic, it's not, but it looks like it's ionic. Okay, so you could call it double replacement. It is a special type of double replacement. Look at this. We'll learn more about this later. See how that ends in OH? See how that starts with an H? If it ends in OH, it's what we call a base, which we'll learn more about later. If it starts with an H, it's what we call an acid. So this is an acid-base reaction. It starts or ends with an OH and starts with an H in no particular order. The acid could come first. Acid-base reaction. Okay, or neutralization. They neutralize each other. Same thing. I'm going to show you a trick with this to balance it. Okay, let's look at this. I'm going to change the ending. See how it says H2O? Whoa. I'm going to change that to the following. H OH. I'm going to put a little line down the middle, even though that is H2O. Still H2O. There's 2 H's and 1 oxygen. So it's still H2O, just in a different way of writing it. Why did I do this way? It helps to balance. It makes the balancing pretty quick. Watch this. It's another trick. There's an H here. There's an H here. This is not an H. Think of that as part of the OH. Think of it as part of the OH, which is here. So you're going to count H's and OH's independently, separately. Okay? So what do I mean by that? Make a list. We have calcium. We have the OH. I'll put it in purple. We have the H. I'll put that in yellow. And then we have the Cl. I'll put that just, okay. Count all of these. These are all ions. Count the ions. How many are there? One calcium on the left, one on the right. How many OHs on the left? Yeah, there's a 2 there. A 2. On the right, no brackets. 1. H's on the left. 1. On the right, don't count this. This is part of the OH. Count the first H. 1. Chlorine on the left, 1. On the left, on the right, 2. Okay, I'm going to make a guess. I may be wrong. Put a 2 in front. Actually, no. Here's a quick way. Here's the trick. The trick is this. Balance the OHs and the H's. They have to be the same on both sides. There have to be as many H's as OHs. So if there's 2 OHs on the left, there has to be 2 on the right. Put a 2 in front. Yeah. This is the trick with this sort of equation. Start with balancing the OHs and the H's. It's a lot faster that way. So that makes it so there's now 2 OHs, 2 of these. How many H's do I have on the right? 2. How do I make it so there's 2 on the left? Put a 2 in front. That balances the chloride as well. So that's the trick. The trick is if you've got an acid-base reaction, start with balancing the OHs and the H's. Do that first. It'll always work. It's a lot faster. Okay, I. Mg3 and 2. I'm going to balance this one real quickly. I want you to tell me what type of reaction is it. Done. I just balanced it. What type of reaction is it? Opposite of synthesis. Yeah. Compound turns into an element plus element. Or a smaller compound plus element. Decomposition. It's decomposing. It's breaking apart. Okay? What do you need to do in order to get this to break apart? When you, in the real big world, called the macroscopic world, in the big world, the real world, not the microscopic world or atomic world, they're all both real, but the world that we're experiencing. What do you need to do to something to get it to break apart? Let's say you had a big stone. What would you have to do to get it to smash? Yeah, you have to use a force. You have to hammer it. So you're applying energy. Whenever you use force, you're applying energy. So same thing with chemical reactions. If you want them to break apart, you've got to add energy. Instead of getting energy out, you have to add energy. There's more energy put in to get it to do what? Break apart like a stone. This is not exothermic. If you're adding energy, you're putting energy into it. It's endothermic. Energy is not exiting. It's not exothermic. It's entering. Entering. Use that to help you remember it. Energy. Action. It's endothermic. Not all, but many decomposition equations are endothermic. You have to add energy to get it to break it apart. So what's on another side note, we'll get more into this later, but what's going to be of higher energy? The reactants or products? This is the reactant. These are the products. What do you think's higher energy? You put energy into it. Yeah, products. This is higher energy. Because you added energy to the system. It's not losing energy. Energy is being added to it. Higher energy. This is lower energy. Okay, J, what time is it? Okay, J, what type of reaction is it? I'm just going to give you the answer. Yeah, elements plus compound. What's being replaced? The metal or the non-metal? Good. This is a metal. Metal always replaces metal. Okay. Sometimes you can have the non-metal being replaced, but that's when you start with the non-metal on the left. Yeah, go ahead. Produces FeCl3 plus copper. I'm going to balance it quickly. I'm taking a guess. Is that balanced? I think so. Good. Okay, that gives me a little more time. Take a mini break, like 1 minute, and I'll set up for 4. 4, I've got to go through A to D. They're longer. Right? 40. Okay, I got time. 1 minute break. I'll write down. Can I take a look at one of your workbooks? Yeah, you don't need it. I'm just going to find something from it. That's what I'm looking for. Homework. Okay. Oh, shoot, my back's still so. Oh, you got a pot belly. Are you like stay at home? Your barbecue dad. That's a polite way of saying it. Okay. Lithium phosphate. I'm going over 4A. Lithium phosphate. I have to write down the ions. Phosphate. How do I know this is a polyatomic? It ends in 8. See how it ends in 8? Phosphate. That's my clue. Look it up. PO4 minus 3. Crisscross because they're different charges. LiPO4. Magnesium sulfate. Mg plus 2. SO4 minus 2. Same number. That means just write down the symbols. MgSO4. Okay. Produces on the right lithium sulfate. I need the room here. Lithium is plus 1. Sulfate, how do I know it's a polyatomic? Ends in 8. Minus 2. Crisscross, you get Li2. Next one is magnesium phosphate. Mg plus 2. PO4 minus 3. Do I crisscross or not? Yeah, the different numbers, like crisscross. Mg3, PO4, 2. Is that right? No, I need brackets. Okay. I'm going to save us time because we're running out of time here. So I'll do this one, and then the others I'll just give you I'll go through how to find the formulas and then give you the balanced equation right away. Okay, for this one, I would, because you've got polyatomics, I would make a list of the polyatomics, see if that works. I've got a PO4 here. I've got a PO4 here. Check. They have to be on both sides. SO4 here, SO4 there. Good. What does that mean? I can include them in my list. Okay. 3 lithium on the left, 2 on the right. I'm going to go faster this time. No brackets. 1. On the right, brackets, which means more than 1. 2. Magnesium on the left, 1. On the right, 3. S sulfate, no brackets, 1. On the right, no brackets, 1. I'm going to take a guess. Put a 3 there. That gives me 6. It also affects the sulfate. There's 3. I need to fix the lithium on the left. 2 gives me 6. That affects the phosphate. 2. One last move. Put a 3 there. Done. I fluked out. Okay. With B, I'll show you how I come up with the formulas, and then I'll give you the answers. Zinc iodide. Zn is +2. You can look it up. Iodide, -1. Okay, copper 1 nitrate. Pardon me, crisscross here. ZnI2. Plus copper 1 nitrate, Cu1 nitrate -1. Just write down the formula, CuNO3. No crisscross needed. Okay. On the right side, zinc nitrate, Zn +2, nitrate -1. How did I know it was NO3? It ends in 8. I looked it up. So the formula is NO3 -1. Different numbers, crisscross. Zn, NO3. Put the 2 there. Excellent. Oops. Plus copper 1 iodide. It's just CuI. Skipped a step. Okay. Balance, I'm just going to give you it right now. I think you're getting used to how to do it. So the answer is 2 in front here and 2 in front here. Okay. C, mercury 2 nitrate. Mercury is Hg +2. Nitrate is, as we wrote down before, NO3 -1. Crisscross. Okay, that's mercury nitrate. Sodium hydrogen carbonate. Okay, here's a new one. Sodium is Na+1. Hydrogen carbonate ends in 8. There's your clue. It is a polyatomic. H3O3. Can you check the charge for me? What is it, please? It's -1. Good. So you just write NaHCO3. Everyone got that? Erase this. Okay. And then on the right side, sodium nitrate. Same charge. So just write down NaNO3. Mercury 2, hydrogen carbonate. Different charges or different numbers crisscross. Capiche? I'll give you the numbers. I think you could do this. 2 here. And then 2 here. You'd be done. Okay? D, I had to do up to D. Just going to give you the answer. Save a little time here. 2N I3 plus 2FES produces Ni2S3 plus 2FEI2. Okay, now here's your, this is an assignment. Okay, now I forgot that. What's that page again? Is it 82 and 83? Page 82 and 83 in the workbook. And I will post that as an assignment now. I was going to make it due. I get you on Tuesday, right? But Thursday's the test. Sometime at the end of Thursday. I don't mind if you want the whole day Thursday after the test to finish it. That's fine with me. Just get it in by the end of Thursday. That gives you, you can weigh the time accordingly. If you want to spend more time on the test and then save the assignment, more of the assignment till the end, that's fine. You got the extra time. But by the end of Thursday. I think you find the test is probably about 40 minutes, 35, 40 minutes. What will take you the extra time probably is the balancing. So, okay, I will post this as an assignment now. Yeah. Did it work? Did I? Oh, something's off, right? I think I wrote it pretty quickly, so I think this is, yeah, so in the answer it says, give me a second. Oh, I wrote it. Did I write it wrong? I wrote it wrong. Too fast. Take your time. Lesson in taking your time. Okay. So page 82 and 83. Okay, there you go. Being assigned now. Also, guys, listen, tutorials, we're going to have to limit it to Tuesdays. I'm running to, my time's getting restricted. So Tuesdays, 1:16. If you want on Wednesdays, I can still do it, but I've got an economics club I'm supporting as well. I have to, you can meet me in 1:16. We'll have to move it to another room, but you have to let me know if you need me for that day, and then we can either work at the back or I'll move you into another room. But preferably Tuesday. Got 2 minutes left. Are you that much of a hurry to leave Mr. C? No. State Farm, are you a salesman?
Yeah.
Nice.
I'm gonna sell you something.
Oh, I need lots to be sold to me. Yeah.
What do you need sold?
I don't know.
I'm basically like a good neighbor.
Gotcha.